Good. So today we're going to try to take everything that we've learned from some of our previous sessions and really start to put it in together into something that you might actually do as a data scientist or a data engineer at a new company. So what we're going to do today is called an ETL process. And what that means is extract, transform, and then load. So what we're going to do first is take data that has been extracted, the E part of our trans or of our ETL. I'm pulling out a whole bunch of CSVs just because it's easier for explanation. In the real world, this would probably be from a SQL query and setting up your Python to pull from a query. At which point, some of these tables you could take for they are essentially all there. You can merge them all together inside of SQL and get a basic report in that shape. Or this might be from a bunch of different databases that all just happen to work on similar keys for how to go about joining them, at which case you would want to do this inside of Python versus trying to do all of your ETL process inside of SQL. So a couple of things as we really start to kick off. SQL is for the extraction part of your ETL process. If you use SQL to do your extract, transform, and load, two things are going to happen. The first, all of your code is going to be extremely complex and hard to move, and it is extremely dependent on what your database is and how it is constructed, which means that when you end up with a new CSV format file, if you're pulling that, or a transfer of your database from one system to another, which happens all the time at major corporations, it means that instead of, hey, I just need to switch out my connector to which database I'm hitting, and it should be fairly easy to pull all of those pieces across, maybe doing a little bit of changing up my SQL code, but very minimal work to switch it over. Instead, you have to go through transforming all of it, all of its syntax, everything, to be able to go and do that. And that's why it's really not best process to do that. The second thing that's going to happen is, especially for some of the more complex things, we're going to be doing very simple things for our ETL process today. But as you start to go into more complex things like creating flags, building out complex merges, going through filtering your data sets, all of that becomes much harder to do in SQL. The writing of that SQL code becomes more complex. And on top of that, every single time you add that complexity to your SQL statement, you're forcing the SQL server to do more than just extract the information. You're forcing it to take on all the compute. And so it might look like it's running very, very fast. And it might run very fast for a SQL statement, but it's taking up resources that are shared resources, and your DB admin is going to yell at you almost immediately for it. The other nice thing about doing all of this stuff in Python is you can go line by line as we're building out our ETL pipeline and see exactly what our code is doing. You cannot do that in SQL. So let's go ahead and get started here. The first thing we're going to do is hashtag import packages. Or the hashtag or pound symbol, depending on which generation you're from, basically is going to comment out our code. We're going to go through and use it to comment in our code, which is best practice, to say essentially what we're going to do on every single level of what it is that we're doing. I'm not going to do that in running through the code today, just because I'm going to be explaining what it does, but understand it is best practice to go back and notate your code through your ETL pipeline. That way, when somebody looks at it in 7 years, they can essentially identify all of that. The other thing that you're going to see me doing for the sake of time and not boring everybody to death is, instead of typing out the code, I'm going to be copy pasting a lot of stuff from a notebook that I've already written. This isn't to confuse you or try to run super fast. understand that all of the code that I am essentially going to be showing you can be created through ChatGPT. That is, that's not what makes a data scientist or a data engineer valuable, is our ability to write code or to get a specific syntax, is our understanding of how the code should be put together and knowing how to solve different levels going through. That is why we get paid to do what we do. If ChatGPT could do everything that we did, then I would already be replaced as a data scientist. So here we go. The first thing we're going to do is import packages. The second thing is you should have found in the GitHub for all of this a whole bunch of CSV files that you can download, put in your downloads file, and then we're going to pull in all of these. So I don't 100% know what all of these different tables do, but I know that based on the data sets that I've been handed by my company, main is going to be essentially where we're going to start our data journey and trying to figure out how to put these pieces together into a pipeline that makes sense. The last thing before we really get started on all of this journey is our prompt for today is we work for a company that does scouting for national teams. So if you have ever watched your national team play some football or soccer, if you're American, you know that essentially the players that come in and play in those teams can be playing all over the world. And so our company is going to provide scouting reports to different nations that come in contract with us, and we're going to try to provide to them a list of candidates that are not already on their national team that they might want to put on their national team. So that's going to be our prompt that kind of gets us through things as we go through today. So we're going to go ahead and run this. We have some sort of player ID. My assumption is that this is what's called a primary key. If you're unfamiliar with a primary key can either be a single column or it can be multiple columns that uniquely identify a row of data. So in this case, Karim Benzema is always going to be player ID 165153 in a database. Most of the time in a database, you will not have any sort of repeated primary key. That's the whole purpose of them. Sometimes with CSV exports, you can have those, or sometimes you can have, when you export what you think is the primary key, you can have duplicate data. And so it will look like everything should be the same, but we see it multiple times. So we'll keep that in mind as we start to go through this data. So the first thing that we notice is that we have a player ID, a short name, a long name, a position ID. This is what's called a foreign key, meaning it's a primary key on somebody else's table, but we can use that to essentially merge that data. We have a club team ID, national ID, or nationality ID, and a national team ID. So all of those things are essentially foreign keys in this primary table. There's probably a primary key out there in one of the other tables. So the first thing that I notice is in this national team ID that some of these are not applicable values. Sometimes those will show up as null, sometimes they'll show up as NaN. It really depends on if you're using Python, PySpark, SQL, however you happen to be pulling this data. But essentially that means that there isn't a value for it. So in this case, Karim Benzema is not on a national team, according to this data. Now, the French have since taken him back after his suspension, but for this data that we're looking at, he is not on a national team. So the first thing that we want to do is we want to get rid of all the people that are already on a national team. If we are scouting and trying to help a national team's manager find new players, handing them players that they already have is not going to be helpful. So we're going to create a filtered DF. So the filtered DF or data frame, we're going to take our main. We'll use that syntax that we have been using for filtering, which is basically table, the column that you want to filter on. And then I'm going to introduce a new concept that we haven't done yet. This is NA. So basically, I want only the values for national team ID that are null values. So that will essentially get rid of people like JS Mertens, who is already on a national team. All right, so let's go ahead and check our work really quick. And we can see, yep, Mertens is now gone. And we now have Chuba Ekpom has made it onto our head list of the first 5 in order for us to take a look at essentially who are our possible opportunities. Now, if we are creating this data set for a customer, they are not going to know what position ID 4 means. I don't, as the data scientist right now, know what position ID 4 means. Don't know what the club ID is, so I don't know what team they play for. I don't know what nationality they are. I'm going to assume that 18 is probably France because I know which team Benzema plays for. But I have basically 3 columns here where I don't necessarily have information that is easily readable to a customer. So let's take a really quick list and see. We've got all of these different tables up here. We're going to start with nationality because we have been told that somewhere in nationality should be what we need in order to figure out what nationality ID is. So we're just going to take a look at that table really quick. And we can see, yep, we have a nationality ID and then a nationality name. Awesome. So as we go through here, what we can do is just a simple merge on the nationality ID with the nationality ID up here, and we can get essentially which country. Now, our boss has very quickly asked us, hey, can we get a list very quickly of all of the countries that we can essentially scout for? And yeah, we can do that. The first thing that we're going to do for him is we're going to be really nice and we're going to put all of the names of the countries in alphabetical order. So all that is essentially taking our data frame again, sort all of the values in the table by nationality name. So if you've ever played around in Excel with filters and you click on the sort by name ascending, this is essentially what it's doing. The next thing that they have asked for is that this isn't a list. I can, if I wanted to, now that this is all alphabetized, go through here and just export the data frame and that single column within the data frame by selecting only that column. But that's not really going to be helpful to our boss. And we are limited by essentially that head. We would have to essentially figure out how many rows we've got, do all of that, and then like take a screenshot for him versus just being able to send him a list. So what we want to do next is take this nationality name and we want to turn it into a list. We're going to call that list country list. And in order to do the country list, we're going to take the nationality and we are going to take specifically the nationality name column, and then we're just going to make it into a list. Do list. Boom. Go ahead, print my country list. And you'll notice we now have a Python list that goes through and has all of these things in it. So if we wanted to do a loop to like loop through and go through, give me everybody for every single country in alphabetical order, or loop for only countries that have a at the beginning of the title. We could use this list and manipulate it, as we've talked about before, to get what we want. In this case, for our ETL process, we're still discovering the data. We don't know what all is in there. So what I want you to do is just really quickly, we're going to pick a country to scout. So we're going to take that nationality table and we're just going to sort it down to essentially a country that we want. And we're going to call that our scout country. So our scout country is the country we will scout for. Awesome. And essentially, we're going to use our same filtering format. You pick any country in that list that you want to. Probably the easiest way to do that is going to be by grabbing that and double clicking to copy paste. I am going to scout for England because that is the national team I support. And I'm going to go ahead and essentially look at what does that new data frame look like. And so here's our data frame. We went from having a whole bunch of countries down to now we have a single country and we have a single nationality ID, 14. So essentially, if we're going up and looking at our table up here for the filter DF, we're going to be looking at only players that have a nationality ID of 14. How can we do that and add in the nationality name England? There's two different ways to do it. Either we could go up to our filter DF and add another filter up here that says, yes, filter all of these by national ID 14. We could do that. And then we could create a new column that is called nationality name and make it literally just England. That is something we could do, but that's a little more difficult than we need to make it. We've already filtered this data set, so let's use those joins that we talked about in one of the last sessions and use that to essentially filter our data set by using an inner join. So we're going to create a new data frame that is called Scout Candidates. It is going to be made up by our filtered data frame on the left. So if we're picturing this out visually in our Venn diagram, I have filtered DF on the left, and I have my Scout country on the right. With our inner join, we are going to say, grab me everything in common between these two data sets where they have the same, and then our on is nationality ID. So essentially, this is going to have the effect of adding in our England column and filtering our data set, our filter DF, down to just England players. Double click on our scout candidates and add in head so that we can check our work. And this is probably the greatest advantage to going through and doing something in Python versus doing it in SQL is it's very difficult to go through SQL and go on a line by line basis and be able to check and or explain your work versus in Python, PySpark, other programming ETL languages, I can 100% on a line by line basis say, hey, I'm going to put a note out here that says filtering to selected country by inner join merge. I have my full logic of what I'm doing in there, and I can check and see, hey, did this work? Yeah, everybody's England. Sweet. And I filtered it down to only the players that could play for England. So I'm the first part of my way through this ETL process of being able to create a sustainable report for the England national team. The next thing that I'm going to do to make my life a little bit easier and be able to see exactly how the data is working on a join by join basis is really quickly, I'm just going to grab a single player. So in this case, I'm going to grab Mr. Akpom, and I am going to filter the Scout candidates data set to just his record. Now, why in the world would I do that while building an ETL pipeline? I'm going to have to make sure that this works on millions and millions of rows in some cases. Well, the reason is I'm going to use him as a test case to be able to see if the number of rows that I return after doing some of these joins and merges is going to be the same as I expect it to be. I'm using him as a single test case. And once I know that he's built properly, then I'm going to take my data or my data set and remove that filter, write this essentially large to the whole data set. And then I'll probably check like 5 or 6 players to make sure that they behave in a similar way. I'll also use probably some other reporting tools that we'll talk about in the next session when we start to talk about how to build an ETL logger on our data set. Those are all things that I want to think about. So I'm going to filter down to just the single player, and I want to make sure that this is only a single row because it would completely defeat the purpose of this exercise if I didn't have a single row. So what I want to do is I want to build out for Mr. Akpom, I want to build out his position ID, his club ID, his nationality. I want all of those pieces to essentially be built out and see what all I've got in these data frames. All right. So the first thing that I probably should ask is what position does this person play? Okay. Going up and looking at our data sets that we've got up here, we have one for positions, one for Scout League we haven't used yet. I have been told by my boss that that has something to do with the clubs. So probably going to use club info at some point. I have player stats and player position stats. Now, it's interesting that I've been given both of these by my boss, but we'll figure out what they do as we start to go through all of these data sets. There's probably a reason that it's collected. And one thing that you will have to do as somebody doing some data science and putting together these data sets is figure out where I should pull pieces of information from where, because sometimes your data is not going to be the same in one location as it is in the other, and one will be more right for a specific situation. All right, so we're going to start by merging on essentially our scout candidate, Mr. Agpom here, and we're going to see what position he plays. Because I have a position ID, I'm going to assume that positions has position ID in it. And we're going to take a look at what this adds in for us. All right, so merging on that, I get a new column that I didn't have before that's called player position, and he apparently is a center forward. Awesome. So now we know what position he plays. Now, one thing we might want to definitely take a look at is we don't want to suggest to the national team really bad players. So we should probably take a look at those two data sets that I was talking about of player stats and player position stats. So the boss gave me both of these, so let's figure out what is in what. All right. Here you might need to take a step back and talk with your subject matter specialist to find out what some of these things mean. As a data scientist, you will deal with huge numbers of different data sets. All of them will have things that are named all over the place. And overall, you might not have all of the information that you need to put the data together, unless you're just really good at pattern recognition. But let's take a look at player stats first. In player stats, we have a player ID, their preferred foot, overall, which I'm assuming is how good they are. Figure it out. Work rate, there's some sort of low/low, or basically we have a combination of two. I don't know what that means, but it probably means something to somebody. And then we have a pace, shooting, passing, dribbling, defending, physical. Okay, so those are probably statistics of how they are on things that are not position related, just overall. So that's what I'm going to assume overall means also. And then we have these player position stats, and what I'm noticing up here at the top, / my content specialist was nice enough to tell me, is these are all of the different possible positions that this person could play and how good we estimate they would be in any situation. So although Mr. Akpom plays center forward, in theory, we've got stats for him if he were to play goalkeeper, which is a little weird, but okay. The other thing that we notice in this data set is this is what's called a wide data set. So it's got a lot of columns going out very, very wide versus a long data set that is, maybe 3 or 4 columns, but just thousands upon thousands of rows. And that's because essentially we have one player ID and then a whole bunch of positions laid out there. This is probably not going to be the easiest in order to try to figure out how good Mr. Akpom is at being a center forward. In its current setup, we could do it. We could do it by going through and essentially saying, yep, their position overall skill at that position is equal to whatever the column is that equals their player position. It would be a whole bunch of if-then statements, and every single time that a new position is added or anything like that, we would have to go through and essentially edit our if-then statement. If-then statements are extremely complex. They are also extremely computational, and they are very inflexible. So when you're thinking about building your data set, only really use them if you absolutely have to. I'm going to show you a better way that we could probably get down to getting the correct position with player position stats. So the first thing that we want to do is we want to go ahead and let's go ahead and merge our player stats with our scout candidate. So we'll start with how good is this person overall? And in order to do that, we're going to take our scout candidate and we're going to merge on that player stats. One other thing to note as you start to go through and build your data set is if you're writing in a different IDE that is not Jupyter Notebooks, you have to worry about this a little bit less. But in Jupyter Notebooks, if you run a cell, it runs that independent of everything else. So it's not going to go back and run this entire notebook from the very beginning. That becomes a problem when we have essentially a data frame that we keep naming stuff into. So we could solve this by going through and making this scout candidates 1, scout candidates 2, scout candidates 3. The problem with doing that is that essentially every single time we build a data frame, it's taking up more memory because it's trying to keep track of all those data frames versus what we're doing right now, which is overwriting that data frame with a new data frame. Keeps it a little bit better on the memory. But we run into the problem as we start going through this that our merges are happening multiple times. So you can see right here, we already had in scout candidates from the last time we merged this that he was a center forward. We now have that he's a center forward again. It's not necessarily helpful. So one thing that we are probably going to want to do as we start to go through this is that we want to keep all of our scout candidates all in one cell together. And what this does is because we are starting with two different things that are not being named elsewhere in here, it will recreate the scout candidates data frame just like we did the first time. And then it will go through and do all these manipulations on it so that when I run this, I don't have multiple player positions. Now we do see a different issue here of we suddenly went from one row to we have a lot of rows. Like how many rows do we have? I have no idea. We have 90 rows. So that means that something with our player stats, it might be that it's a version table, in which case it's got multiple versions of that player's statistics in them. I don't necessarily know what's going on other than I know that these definitely all look to be the exact same statistics on the 100 or so it's showing me. So let's go ahead and correct this. Before we do anything with merging these, we're going to get rid of the duplications for player stats. If you remember doing this last time, basically it's take your data set, it equals your data set, dropping the duplicates, and then you have a subset. So these are all the things that must be identical in order for us to drop a row. And it will keep the first of that row. So what I'm going to do is essentially drop duplicates on player ID, which means that player ID has to be a unique value. Other than that, I don't necessarily care what's in the rest of them. Just drop it and keep the first player ID for each player. Now, when I go through and do that, we can see, hey, cool, we're down back to one row. And this is part of why I like going through and doing maybe one or two just test cases as I'm building a data set, especially when I'm new to the data and don't necessarily know how it functions, is I could run into that and be showing ahead where, scout candidate and everything. And I might never notice that there are hundreds of duplications of these lines in my data set. And suddenly I'm now handing a report to a manager where ACPOM is on there 100 times, and I have a very angry manager asking me, what in the world am I doing as a data scientist? Okay, so we've got how good is that player overall? The next question we need to ask is that how good is that player in the position? And I told you I was going to come up with an easier way to essentially get all of the data so that we can join it very easily. So I'm going to go ahead and throw up in our statement up here, how good is that player at that position? And we're going to look at this player position stats head. So to make our lives easier, it would be great if all of those column headers were suddenly all in one row. Because if they were all in one row, then I could just do, or sorry, all in one column, then I could just do a simple merge um, with our joins of, hey, I've got player ID, I've got the player position, just give me the value that's there. There's a way to do this. It's called melting. And essentially what we're going to do is we're going to call a pandas function that's called melt. We're going to give it a data frame. We're going to give it the data that we want it to keep in individual rows. So the things that we don't want to change. So in this case, it's going to be player ID. So I want player ID to stay in the column player ID. Don't move that. What I want to happen essentially is I want I don't 100% know how wide this is. Let's see if it will tell me. I want the other 27 columns that are in here. I want one row for each of those positions for player ID 158023. So instead of having one row for that person, I'm going to go to having 28 rows, or sorry, 27 rows for that person. Each one will have a different one of these column headers in there, basically saying the position. And then I want the value that corresponds with it. So essentially it'll be player ID of this, their position will be left striker, and then they will have a player position score that is 87 plus 3. We'll figure out how to deal with these like weird pluses and minuses here in a minute. Anyway, so what I want to do is I want to use this melt command. And the first thing that I'm going to do is I am now completely and utterly paranoid that I'm going to have multiple rows for the same person before I even get started, which would, if I'm going from one row to 28 rows, I don't want to think about what it would be if I had 100 rows for that. That's a lot of rows that I'm suddenly adding. So first thing I'm going to do is I'm going to drop duplicates based on that player ID. Awesome. Now that I've got that, I want to go through and melt our data frame. So I'm going to create this melted DF. I'm going to give it the data frame that I'm going to mess with, which in this case is player position stats. Like I said, I'm going to give it the ID vars next. So what do I want to be my ID column? Or what are the columns that I don't want to suddenly be exploded out into a number of things? So player ID. I'm going to give it the name of the new column that I want. So that's going to be essentially what all of these are. So any columns that I have not named in this ID vars are going to go into this new column that's called player position. And then the last thing is, what do I want to name the column where their corresponding values are going to go into? I'm going to call that one position score. Now that I've got that, I can take a look at this melted DF and we can see, all right, sweet. My player ID, I now have all of the left strikers and I've got their position scores. One problem. Python can be very case sensitive. My player position in my main data set right now is all capitalized. I need to make player position also capitalized. Cool. Easy enough to do. If you want to manipulate a single column, just call out that column. So in this case, I want melted DF player position, and then I want to do something with it. I want that column to essentially be the same thing, but I want it to take that string and make it all uppercase. So when I run this, now we can see all of our stuff is capitalized. Awesome. We're going to do the same manipulation with position scores, but we're going to extract some information. We're going to extract all of the pluses that are in there, turn that string column into integers, and add it all together on the same level. Say that again. We're going to take the column that is a string column. So right now, 87 plus 3 is not an integer. It can't be added. It's just a string. We're going to extract from it all of the D pluses and then sum them. So I'm going to go through and essentially do that and sum them on a level of 0. So going to go ahead and run that. And we can see, cool, now all of our like 87 plus 3s, those have all been essentially merged in. So we're good to go on that piece. Now all we have to do is take all of this and merge it back to our original scout candidates. So we're going to take all of this stuff. We're going to move it up here under our comments. And then we're going to go ahead and merge that with our scout candidates. All right, so in theory, we should have a single row and we should have the center forward position score for our candidate now. Go ahead and run it. Sweet, we have a position score of 70. So overall, he's a 72, but playing at center forward, which is where he's supposed to be, he's at a 70. All right. Two more pieces of information that we need to essentially get for our customer. We've got the position. We need to know where that manager needs to send their scout. So I've been told we've got club team ID. I've been told by my boss that if I merge and merge on club team ID with the club info, that I should be able to find out what club this person plays for. So we'll go ahead and do that. All right. So he plays for Middlesbrough. Just trust me that that's how it's pronounced. I realize that's not how it looks. We also see that we added another column in here that's called League ID, which is interesting. We now have essentially a club and a league ID that is going to link us to yet another table. So the only table that we haven't touched yet is that Scout League, other than playing with it. Sorry, we haven't touched that table at all. So let's go ahead and see what happens if we merge on that league ID. What do we get? All right. So we've got all of our original IDs, preferred foot, overall, Middlesbrough, and then, ooh, we've got two new columns in here. One is called league name. So he doesn't play in the Premier League for England. He plays in the Championship, which is one league down. And then he plays in England. This is important because a lot of like the leagues have very similar names or are indeed the exact same thing. There are multiple Premier Leagues all over the world, so it helps to know which country um, we're talking about for which Premier League in there because I doubt that very many managers are going to have an encyclopedic knowledge of where every single club plays, especially when some of the clubs share names or IDs. Alrighty. So pretty cool here. We've essentially gone through and built out a report that goes through and filters down for a single country with a single score level or anything like that. So now that we've got this, we need to turn this into something that somebody can use. So the first thing I'm going to do is I'm going to go ahead and get rid of our merge, and we're going to go through and essentially go ahead and grab everybody. So here is, in theory, all of the people that somebody who is searching for England national players could be looking for. This report in and of itself, if I wanted to, um, if this is going to be a notebook that I just want to hand to somebody and let them run over and over and over again, um, I can go ahead and put um, what are called global variables at the top. So if this is going to uh, be our data set, and I want to make this repeatable and so that I can easily edit over and over and over again what's going on, I can create what are called global variables. And a global variable just means that it pertains to the entirety of the notebook, or it's designed to. So I'm going to insert a cell above, and I'm going to create one of these variables. By essentially running this cell, now that I've created this variable out here and I've made my country name equal, it will go through and essentially replace country with England when I run the code. So if I run this, it'll show up exactly the same. If you are building out a report or a data set, chances are you're going to want to build something that's a little bit more like this in terms of its actual functionality. So one I deal with constantly at work is date filters. I want to look at a specific date range and I want it to be dynamic and I want this book to run every single day and I don't want to go in and manually change the date all the time. There are ways of going about essentially doing that. I set it as a global variable and then it runs through every single time. There is another way to go about doing this. If you are working for a company that needs a defined function, meaning they have a website that is going to use some of your data engineering skills to go out and pull different pieces from the database behind the website, they might ask you to create a defined function. I want to be clear here. Defined functions are things that should be done over and over and over again based on a set of minimal inputs. They should not be something that, hey, I want, a defined function here where I'm going to define join tables together as my defined function and basically say, yep, give me your left, your right, and what they should be joined on, and then we'll call it that. You're not saving any code by going through and defining a function. Define join up. Just give you an example of what this would look like. Um, df1, df2, and then columns. Perfect. df3 equals df1 dot df or dot merge df2 on equals all essentially going through and defining this as a function and then calling it of scout candidates equals join up, boom, boom, boom. You can see that I have not saved myself lines of code. In fact, I've added lines of code. This is not Pythonic. Pythonic is to use as few lines as humanly possible to essentially do this. And I'm not doing that. I will not use this same piece of essentially merging stuff or this command of how to go about breaking things up over and over and over again in my ETL process. Not in any sort of thing that is going to constitute like I need to define a long drawn out function so that I can write that function once and save myself writing like 10 lines of code. Chances are, as you go through an ETL process, as you're going through and building this, you're going to do each of these things to the data set once and you're never going to do them again. So writing them as a defined function doesn't make sense. So we're not going to do that here. We're just going to say this is our run. But like I said, if you are working for a company that wants you to go through and have a defined function that it can then use to call to the database and get the specific information back, you might want to go about defining a function. So how do we do that? Well, I kind of already cheated and showed you some of it. I'm also going to essentially copy paste this and explain it very quickly to show you a defined function, but it's all things that we've already done. So here's our defined ETL pipeline one. I need a client nation and a position that they are looking for. Okay. They don't have to give me a position. They could ask for it, just give me the full list of everybody who is out there. But I need to be able to give them the option through the web page to select a position if they want to. And then essentially you notice that we've got everything that I kind of just showed you of we're going to filter our nationality down to our client nation. We've already done that in our ETL process. Scout candidates is just the same thing that we did. One thing that is different here is this if position is none. What I'm doing here is if they were to put none in here for their position, meaning I don't care, I just want any possible player that is out there for my country, they can put none. And if they put none, I don't want to filter it. So if position is none, my table equals my table. Don't do anything. Don't change anything. If they are to give me a list of positions, like I want only center forwards and strikers, I want only right wing backs, I essentially have set that up as a is in. I don't know if we've necessarily gone over this as a filtering piece, but like the is NA, is in basically goes through and says, hey, do a whole bunch of or statements over and over again. So the scout candidate player position must be center forward or striker or this, and basically shove all those data sets together. That's how that filter operation more or less works. So that's what I've got it set up to do is if they don't give me a position, don't filter it. If they do, filter it down to that position. The rest of this should look fairly familiar. We've got our melts to get everybody down to the player position and score. grab our scout candidates, merge everything in. The last thing that I put in here is just a simple aggregation. We kind of went over this in the last session with playing with group buys, but probably what my customer is going to want first before they give me a, hey, give me the list of all of the players, is they probably want to know where is going to be the best um, place to send their scouts. They don't have unlimited funds to just fly people all over the world. So what they might want to look for is, hey, give me a count of how many players I've got in the country that you're suggesting I go scout in, and also tell me about how good they are. Because if everybody who's playing in the US has an average position score in the 50s, probably don't want to send one of my scouts there when I can send them to Germany and there might be fewer people there, but their average position score is something like the 80s. So what I did at the very bottom is just do a really quick scouting report that gives an aggregated row count and then what is their average score, and then have it essentially descending for both. So it's going to grab the highest number or the highest average score and then the row count and then essentially create that. The last part of any defined function is what you want that defined function to return. If I run this function without a return, I can't save any data frame that it creates in this entire piece outside of that defined function. So if I ran this and said, hey, give me scout report, and I didn't have that in my return statement, and I then tried to call it outside of the defined function, it would have no idea what scout report was. It doesn't exist outside the defined function. So I'm going to have it return to me two data sets. One is called scout candidates, one is called scout reports. When I run this pipeline, I will pick new names for them if I want to. So let's go ahead and run that really quick. I'm going to run a really quick pipeline. So I'm going to go ahead and define this. And you'll notice that there is no data coming out of it because I haven't asked it for anything yet. I've just defined what it's going to do. Now I actually want the exports though. So give me candidates, comma report. So that's essentially my scout candidates is now going to be renamed candidates, and my scout report is going to be named report. I am calling my ETL pipeline 1. I'm giving it my client nation, which is England, and I put position none. Let's just see what's out there for right now. And then really quick, just give me a report with the top 100. All right, so looking at this, there are a bunch of England left backs, center attacking mids, going all the way down here through France has a goalkeeper apparently that is English and could play for the English national team. The next part of this is going to be a really quick filter down. So I'm going to go back to my defined pipelines. Normally you would define your pipelines at the very top of your notebook, but we're kind of going through this on a lesson basis. So I'm defining them here. Normally you would define them at the top of your notebook. I'm going to go through and I'm going to define a second function. And the second function I'm going to define is I want to take that scout candidates report that I got back that I'm holding right here in candidates. And I want to go through and be able to essentially filter that to get exactly what the manager wants. So if he looks at this list in this first report and says, all right, give me all of the right backs from England and also some of the strikers. Can you do that for me? Essentially what I'm doing is give me a data frame. You'll notice that data frame keeps the same name all the way through here. And it's because data frame here can be whatever I want my input to be. So when I run this pipeline, whatever I put in here for the data frame, it will change the name as it goes throughout. And then give me the scout country and the position that you want. Data frame, filter the data frame down to scout country. We already talked about the position piece, and then sort the values. So give me their position score and the club name ascending, false and true. So what this means is essentially give me the club, or give me the players in the club that they play for in alphabetical order with their position score descending. So I'll get the best player from each club for each of the positions that I'm talking about. And then the last thing is there are a lot of things in this data frame up here that I did not go through and get rid of. But the customer has asked me for hey, this is how I want my data. And it could be that's how the website displays the data, and so that's how they need it back. It could be that, the report that gets emailed out, the customer uses that and drops it into some sort of other ETL pipeline, and so they need the columns in a direct order. That's pretty much all I've done here is I've gone through and picked out the columns that actually matter, that are readable to the customer, and then put them in an order that would make sense for that customer. So club name comes first, the player's long name, what position do they play, what is their work rate, pace, shooting, all of those, positional score, and then their preferred foot, because preferred foot is probably going to be the thing that they care about the least. I'm going to run the cell again to get my new defined pipeline. And then I'm going to take that candidates report. And I'm going to go through here and I'm going to say, hey, using that candidates report that was built out of ETL pipeline 1, go through and give me everybody from Scout Country, England. So we're not going to get any French goalies or anything like that. And then give me the position striker, right winger, and right back. That's what we're looking for now, apparently. Go ahead and run it, and you can see, awesome. We have essentially the club names and the player positions, and then their overall position score, essentially going down through here and giving us the information on who the coach should be looking at. All right. There are a whole bunch of little tiny things inside of building an ETL pipeline that you're just going to have to figure out as you go along. And every single ETL pipeline will be different. Some of them will be as simple as the one that I just built for you. Other ones will be much, much more complex. The last thing that we're going to do before we call this a session is essentially we're going to go through and we're going to write both of these reports that we've created to a CSV file. The reason is in the next couple of sessions, we're going to go through how to use those CSV files and writing CSV files to go through and tell you if something is wrong with your ETL pipeline. So we're going to do loggers next time and how to essentially do all of that. And then the last session that we're going to do is on using an email bot to not only email your reports to who you need them going to, but also to email you saying, hey, your ETL pipeline ran successfully or it didn't run successfully. And here is all of the log information on where your pipeline could have broken. So that's what we're going to do with the loggers in the next section, and then the email for the final one. But essentially, all we're going to do is take the data frame to CSV is the call for it, and then say where you want to put it. You'll notice I have this index equals false. If you leave it as true, you will get a blank column at the beginning of your CSV file that has this index in here. This index is not important to anybody other than your Python Jupyter Notebook. So keep that in mind as you go to export CSVs. Chances are you're always going to want to put comma index false for writing to CSVs. But essentially, we go ahead and run it at this point. Great work. Hope to see you next time.